the today for? It is the beginning of always. Things are pretty, graceful, rich, and elegant, but until they speak to the imagination, they are not beautiful. With our minds and souls marching towards the progress of the students' community, technical development, and towards the blooming future, we are here to celebrate National Technology Day. Just as a candle cannot burn without fire, men cannot flourish without a spiritual life. Faith is the strength by which the shattered world shall emerge into light. Let our minds and speech unite to invoke the blessings of the Almighty. A warm good evening to one and all present here. On behalf of our Department of Information Technology, I extend a very warm welcome to each and everyone present here to celebrate this National Technology Day with our beloved chief guest, Dr. P. Karthikeyan, Post Director, Researcher from Taiwan. Let us seek of bountiful blessings of Almighty to propose us on the path of success. Prayer song by our sister.
ஓம்காரநாதம் நீயே உண்மை பொருளும் நீயே உந்தன் அருள் ஜோதி எங்கும் ஒளி வீசவே இந்த புவியோர்க்கு அருள் செய்வாய் ஓம்காரநாதம் நீயே ஹேராம் என்றாலும் நீ இயேசு என்றாலும் நீ எங்கள் அல்லானே உலகில் எல்லாம் நீ எங்கள் உள்ளத்து தெய்வம் நீ ஓம்காரநாதம் நீ உண்மை பொருளும் நீ உந்தன் அருள் ஜோதி எங்கும் ஒளி வீசவே இந்த புவியோர்க்கு அருள் செய்வாய்.
Thank you, sister. National Technology Day is observed every year on 11th May across the country. The day commemorates the achievements of engineers and scientists in the fields of science and technology. During the ongoing pandemic time, the day holds a special significance. Modern technology has emerged as a key to save the human lives today through inventing COVID-19 vaccines or instruments for artificial oxygen for patients counting their breaths. On 11th May 1998, the first indigenous aircraft, Hansa 3, was test flown at Bangalore. India performed a successful test firing of Trishul missile on the same day. At that time, very few countries have nuclear power, and India has become one of those elite players and became the sixth country to join the nuclear club. Operation Shakti, Pokhran 2, on 11th May 1998 was initiated. Every year on this day, the Technology Development Board of India awards various individuals with national awards for their contribution to indigenous technology. Therefore, we can say that this day glorifies the importance of science in our day-to-day life and motivates us to adopt science as a field of career.
Welcoming the guests wholeheartedly is our tradition. I kindly call upon K. Soumya from second year of Information Technology to welcome the gathering.
Imagine with all your mind, believe with all your heart, achieve with all your might. A warm good evening to one and all present here. It is a matter of pride and privilege for me to deliver the welcome address to this august gathering. I consider it is a great honor to welcome our chief guest, Dr. P. Karthikeyan, Doctor Researcher, Department of Computer Science and Information Technology, to make the function memorable one, not only by their presence, but also by their valuable guidance and informative thoughts. Welcome you, sir. I heartily welcome our principal, Dr. M. Premkumar, President of Institution Innovation Council, Paavai Engineering College, and also Chairman of IST chapter, for the great occasion to preside over the function. Welcome you, sir. I heartily welcome Dr. K. Sundaramurthy, Vice President of Institutions Innovation Council, Paavai Engineering College, for the great occasion. Welcome you, sir. It is a great pleasure to welcome Dr. R. Moganapriya, the convener of Institutions Innovation Council, Paavai Engineering College. Welcome you, ma'am. It is a great pleasure to welcome Professor B. Venkatesan, HOD, Department of Information Technology, and also Secretary of IST chapter. Imagine with all your mind, art, achieve with all your might. Yeah, good evening to one and all present here. It is a matter of pride and privilege for me to deliver the welcome address to this august gathering. I consider it is a great honor to welcome our chief guest, Dr. P. Karthikeyan, postdoctoral researcher, Department of Computer Science and Information Technology, to make the function memorable one, not only by their presence, but also by their valuable guidance and informative thoughts. Welcome you, sir. I heartily welcome our principal, Dr. M. Prem Kumar, President of Institutions Innovation Council, Paavai Engineering College, and also Chairman of IST chapter, for the great occasion to preside over the function. Welcome you, sir. I heartily welcome Dr. K. Sundaramurthy, Vice President of Institutions Innovation Council, Paavai Engineering College, for the great occasion. Welcome you, sir. It is a great pleasure to welcome Dr. R. Moganapriya, the convener of Institution Innovation Council, Paavai Engineering College. Welcome you, ma'am. It is a great pleasure to welcome Professor B. Venkatesan, HOD, Department of Information Technology, and also Secretary of IST chapter. Welcome you, sir. And also, I welcome our event coordinator, Dr. P. Tyagarajan, member of Institution Innovation Council, and also faculty advisor of ISTE. Welcome you, sir. I also extend my cordial welcome to all the HODs, staff members, and my dear brothers and sisters. I once again welcome you all.
Thank you, sister. And now I request our most respected Dr. R. Mohanapriya to give her presidential address.
Ma'am, Maunapriya ma'am, are you there? Ma'am, you can speak, ma'am. Now. Maunapriya ma'am, are you there?
Good afternoon to one and all gathered here. So, being a convener of Institutions Innovation Council, I would first like to put my sincere thanks and hearty welcome to Professor P. Karthikeyan, who is a postdoctoral researcher, Department of Computer Science and Information Engineering from Taiwan. Welcome you, sir.
Thank you, ma'am.
So, this National Technological Day celebration of every year, it is being celebrated with certain themes. And this year, the theme for the celebration of National Technology Day is Integrated Approach in Science and Technology for a Sustainable Future. So, we youths and youngsters, we have to remember this day every year. This day is where we remember the achievements of great scientists, researchers, and all engineers in this tremendous innovation world. We should also remember about the great Nobel Prize winners and laureates like Thomas Alva Edison and many scientists who have done a lot of inventions. So being youngster and being a youth, every day try to do small achievements and try to invent new ideas, because innovation, technological projects are where the youth has to focus a lot to pursue in the field of science and engineering. So I thank the IT department as well as the ISTE for giving me this opportunity for this address. Thank you all.
Thank you, ma'am. Now I request our Honorable Chief Guest, Dr. P. Karthikeyan, to deliver his keynote address.
I would like to thank the management and the organizing committee for giving me the wonderful opportunity to give a talk on the computer vision on this technology day. Actually, I'm happy to say that I also worked in Paavai institution in 2007 to 2010. I worked in Paavai institution. No, actually, I wanted to remember in that during that day, no, if I wanted to use internet, I need to pay 3,000 per month. Okay, at that time I don't have that much money. I used to come to this Paavai institution there, no, computer lab. I used to come on Saturday, Sunday. In the holiday, I used to come and I sit in the lab. I do small practical experiment. Okay, actually that no, actually that is a base for my research. Okay, no, I started my research in the Paavai institution in 2007. Okay, I wanted to remember, no, those experience on this day. Actually, I thank the Paavai, the institution to provide the facilities like computer system with internet connectivity, the other facilities they have provided. Actually, the computer vision, it makes the computer to understand the image and video. In the computer vision, using the computer vision, we have to make the machine to understand what kind of scene, where are the cars, how far is the building. For example, actually you have to train our computer to understand, okay, what is this description of this picture, okay, how many the car that is present in this picture, like that we have to train our computer to understand the image and video. Actually the basically the video, it is a combination of image only. Actually, before going to start this session, we have to understand the difference between the computer graphics and the computer vision. Actually, in the computer graphics, usually we will give the description of scene as a input and the output will be image. For example, even in the computer graphics, Now what we will do, if you want to draw one line, you have to give some description about the line. For example, what is the x coordinate, y coordinate, all this coordinate you need to give. The output bit will come as a line. Whereas in the computer vision, no, you will give an image. The output will be the description of the scene. For example, if you give an image, the computer vision, what it will do, it will count how many people, no, even it will recognize the face, even it will track the people where they are sitting, how they are moving. For the purpose, no, we can use the computer vision. The computer vision is it is a combination of engineering, biology, psychology, and computer science. You don't think that the computer vision, no, it will come, no, under computer science. If you want to learn the computer science, you should have no, you should know all this knowledge. The question may comes in your mind, why the computer vision is so popular? Everyone know they will do this project in the computer vision. Even no, I am doing the project in the computer vision here. No, the question may comes in your mind. Even not only computer vision, this artificial intelligence, data science, machine learning, deep learning. No, why it is so popular? No, the question may comes in your mind. Even when I was studying my BTech in 2005, no, at the time also there is a subject called artificial intelligence, but no one is interested to the project in the AI. In 2005, no one is interested. But now, why the suddenly, all the university and college, everyone they are starting the course like data science, artificial intelligence, the machine learning, like that. All the institution also they are starting the course. Why this? All the speed, all the field it is so popular. The reason is, for example, initially in the year 2010 and 2012, actually this red line it indicates the human error. Okay, the human error it is constant. The human error it is always constant. It is a 20%. Let us assume the 20%. In 2010 also it is 20%. 12 also it is 20%. You cannot increase the human error. But you see in the computer vision error, no, it is reduced. It is reduced in currently, it is less than 20%. Okay, now if it is reached less than 10. Not only this reason, actually, I wanted to remember one of my friend, he was working in the Indian Institute of Science in in 1990. No, at that time, even if he wanted to use a computer, he has to go to the lab and he has to book. He has to go to the library, and in the library, he has to book the computer. No, then after month only he will get the computer and he will be allowed to use. Okay, that is why in the in the 90, actually the artificial intelligence it was introduced in the 1950 itself. It was introduced. Yeah, the data science it is introduced in the 1960. The deep learning it is introduced in the 1970. All this technology it was introduced in the actually it was introduced in the 1960 or 70. It was introduced, but no one was they are not able to do the experiment. The reason was at that time we are having less amount of computing power as well as the less amount of data. Now we are having the huge amount of computing power, huge amount of data. That is why you can easily do a project in the AI or machine learning or deep learning. Even for example, you can take 100 or 300 or even the 10,000 terabyte of data, and you can analyze and you can extract the meaningful information, as well as you can make your deep learning model. It was not possible in the 1990. The reason at that time, even if you want to use a computer, it is very it is very tough. Okay, that is why in the current currently we are having the huge amount of computing power as well as the huge amount of data. Even if you want to make any AI model, easily we can make it. Actually, there are some application I wanted to show you. For example, the optical character recognition also it is the best example for the computer vision. For example, in the scanning, automatically it will scan and it will it will understand the image and it will print the result. Even in the license plate reader also, no, actually in the the developed country, automatically they will detect the license plate. In the license plate, if any vehicle, if they are violating the rules, automatically they will detect for that person. Automatically the amount will be charged. And so these are the the simple application of computer vision. Now actually this the Amazon Go, actually this Amazon Go is, it is on computer vision most advanced shopping technology. It is available in the USA. Actually, I will share this PPT to your the organizing committee. The later they will share. Later they will give this material. You can watch this video also, or else I will no, I will only this video I will show you for only 1 or 2 minutes. Then after that, what we will do, we will start our session. Actually, it is very important. Okay, later you can watch this video. Actually, the objective is very simple. Actually, in the USA, if you want to go for shopping, you can go to the market. The there you can take your what you want to buy. You can take the product and you can keep it in your bag and you can come out automatically. In your account, automatically the money will be credited. Okay, they are using this object detection and recognition technology. Using this technology, they have developed this application. The Amazon Go it is the best example for the a computer vision application. Actually, you don't think that in future it will come. The currently they are using in the USA. If you want to buy anything, you can go to the shop. The initially, you should have to use your card. Automatically your bank account information, it will be taken, like your account number, it will be taken. You need to give access rights. Then you have to go to the shop and whatever you want to buy, you can take out and you can come out. Actually, there is no need to generate a bill. There is no need to do anything. Okay, it is a very simple as to technology. Using this technology, they have developed this application. Like this, there are n number of application. It is available even in the USA. If you want to deposit a check, what you can do, you can fill, you can fill your check and you can take a photo. Then what you got to do, you have to submit into the bank. Automatically, what will happen? The check, the Bank of America, they are using this technology. Automatically, what will happen? The money will be credited in your account. Okay, you need not go to the bank and you need not fill the challan and you need not submit to the bank. This technology, you don't think that in the future it will come. The currently it is available. Then the full self-driving car also it is available. This car also it is based on the computer vision technology. Then in the agriculture also they are using the computer vision technology. For example, if you want to click the fruits, automatically they will detect. Automatically they will pick the fruits and they will keep it in the box. Okay, this technology also it is available. Then the object detection also it is one of the example. it is one of the big application of computer vision. Actually, currently I am working on this object detection. No, the question is comes in your mind. The all this object detection, all this computer vision. The best thing in the deep learning is a convolution neural network. But actually, in the if you want to do this computer vision, the fundamental what you want to learn, the first thing you want to learn from the deep learning. In the deep learning, you have to learn the computer. Actually, you have to learn this computer vision. If you want to learn, you have to learn the convolution neural network. If you want to do your project, or else if you want to do your research in the computer vision, you have to learn convolution neural network. In the deep learning, generally it is classified supervisor and unsupervised. In the supervised, the ANN, the artificial neural network, it is used for only the regression and classification. You cannot apply the computer vision. You can apply, but it will not give the good accuracy. If you want to do any computer vision, any image and audio related application, if you want to develop, you have to study this convolution neural network. If you want to go for time series analysis, you have to go for recurrent neural network or LSTM. If you are having the time series data, you have to go for this. In the unsupervised, for example, if you want to detect the feature, you can go for the self-organizing map. Or else, if you want to do for the recommendation system, you can go for auto encoder. As well as even if you want to work with the recommendation system, even you can use the deep Walton-Man machines. Using this, you can build it. If you want to do the computer vision related application, you should have the basic understanding of the convolution neural network. If you are not having the basic understanding, it is very tough to learn. Actually, the computer vision, convolution neural network. Then apart from that, the next one is the data set. There are 3 dataset it is available. The one is ImageNet dataset, the another one is a COCO dataset, the third one is a Google Open Image dataset. I will give this link later. You can learn. Even in the internet also you can search and you can open it. I will show you how to use this dataset. The COCO it is a well-known dataset. It is used in the computer vision. In the COCO, actually, for example, if you want to build any object detection or object recognition, or else if you want to build a computer vision application, you need a data set. For example, if you want to make your data set, it will take time. Reason, for example, you have to download the million of image, each and every image you have to generate the bounding box. Then, after that you have to, say this bounding box it is belongs to a person, or this bounding box it is belongs to umbrella. Like that, you need to do. Actually, it is a complicated task. That is what you can do. You can come to this site and you can download the data set. For example, I will show you. I will know. Actually, in the data set there is a button called Explore. If you click this Explore, you can, for example, you can check the person. Let us assume I'm selecting the umbrella, then bag. I'm handbag. I'm selecting 3 things and I'm searching. You see, actually, it is you see, actually this is some image. In the image, this automatically, they have segmented. Automatically they have segmented. Okay, this is the umbrella. This is the handbag. Okay, it is they have some segmented. Okay, this is the person. Okay, this is the handbag, this is the person, the umbrella, whatever I have selected, they have segmented. Okay, they have generated this data set. This data set, it is freely, it is available. You can download and you can use it for your research. Okay, if you click this download button, automatically this you can generate the data set. Even if you want to do the object detection, key point, if you want to work with this project, for example, if you click this object detection, they have given some challenge. Okay, they have given some challenge and you can take this project and you can work out and you can submit. Okay, if you submit, finally you will be awarded the result. For example, actually there is a link. if you go to this link, they will give the objective. Okay, they will give the project details, and you can work out. Even actually the generated result here you need to upload. Okay, they have given this project details. The evaluation code also they have given in the GitHub. The evaluation code also they have given in the GitHub. You can go to the initial code and you can download it and you can use it. Okay, this is the initial code. Even if you want to work with the Python, you can download Python. If you want to work with the MATLAB, you can work with the MATLAB and you can submit. The finally, you will be given the money. Okay, these are the COCO data set. Actually, this I will show you the other data set. The Google image also it is important data set. In the you see in the Google image data set also here, if you click, directly you can download. If you want to explore about this data set, you can click this explore button. Okay, here what you can do, you can choose the category. For example, you can choose the category as Apple. Okay, you can choose this segmentation. Okay, if you choose the segmentation, only it will do it will segment the Apple. Suppose if you click this detection, then automatically it will detect. Actually, listen, my dear student. Actually, if you want to do the project, for example, if you want to develop an application for the Apple detection, okay, it doesn't mean that you have to generate your own data set. Okay, what you can do, this data set it is available. You can download and you can use it. Okay, here what happened? This is the sample input image. Okay, this is the input image. This is the Apple. This is the bounding pass. They have they have downloaded the million of image. Each and every image, they have given this. They have labeled. Okay, you can download this image and you can directly input. You can give an input to your deep learning model and you can make your object detection model. Okay, these are the the Google data set. It is available in the internet. The third one, actually, the ImageNet also it is a well-known data set. Then actually the TensorFlow Hub, what they have done, they have developed the object detection model. They have developed the object detection model. Not only object detection model, they have the TensorFlow is a well-known framework. If you want to learn the deep learning, you should learn TensorFlow and Keras. The TensorFlow it is a low-level interface. Wherein you have to write your code from the scratch, whereas the Keras it is a high level package. Okay, the only easily you can write a code. You see here, you see this is the object detection, the style transfer, all the code already it is available. You need not do anything. Just you can install the TensorFlow and you can import and you can do your object detection algorithm. And you can develop, it is a 10 line of code. Using the 10 line of code, you can complete the project. Actually, when I was in the 2009 or 10, at the time, I was developing a simple application. At the time, I have written a code for the 1000 line. Now the same thing, you can achieve it only in the 10 line. You see, you can download this. This is the object detection model. You can download and you can use it. You see, this is the image. In the image, it is detecting wherever the person, the kite, all the object it is detecting and it is printing. Okay, this is the simple line of code. The TensorFlow Hub, they are providing this service. You can download and you can use it. No, you should understand that. Already I told you that even we can use the artificial neural network. Using that artificial neural network, also you can do the computer vision task. But using the CNN also we can do. You should understand the difference between the ANN and CNN. It is very important. Then only you can know you can build your own CNN model. The reason is actually in the ANN, no, in the artificial neural network, if your image size is 28 into 28, let us assume you are no, let us assume in the image sizes, if it is 28 into 28, you know, it will be, you know, easily you can do it. For example, if your image size, if it is 1922, 1080, the three it indicate it is a color image. Let us assume this is my image, this is height, this is width, this is the RGB. Now what will happen? You have to multiply all these three numbers. If you multiply all these three numbers, no, in the first layer of neuron, you have to use the 6 million. Even in the hidden layer, even if the 2 million of parameter, even if you omit, in the hidden layer, you may use, you know, the 4 million. Then the weight, you know, the parameter between your input layer and the hidden layer, no, you will have the 24 million. It is very, you know, it is your computer, it will take huge amount of computing power as well as it will take the huge amount of memory. Okay, that is why, you know, the artificial neural network, it is not suitable for the computer vision related application. So that is why what they are doing, no, they are developing the convolution neural network. Okay, using the convolution neural network, no, you can solve this disadvantage. It will take the too much in computation. Then as well as, you know, in the ANN, if the if your object, if it is located in one particular location, even if the location, if it is not changed, you know, then automatically your ANN will not detect. Okay, the location of an object in an image also it matters in the ANN. For example, in your training image, let us assume the person is standing in front of the car. You have trained your model, you know, and you are giving one more image. The person is not standing in front of the image. The person is, you know, he's standing in front of the tree. Then no, your model it may not predict. I will take you one simple example. Through this example, I will explain, you know, about this convolution neural network. It is very, you know, even the 10th standard student or even in the 8th standard student, they can understand by this example. You see, actually this is the koala. You want to detect whether this, no, you want to make one computer vision related computer vision application. Using that application, what you have to do, you have to check this image is koala or not. That is our objective. If you want to detect the if you want to classify whether this image is koala or not, for that initially what you have to do, no, you have to detect these features like eyes, nose, and ears, and you have to make as a head. In the first layer of CNN, what they will do, no, they will detect all this eye, nose, and ears, and as well as in the, you know, they will detect hands and legs. Then using this, they will make as a body. Actually, this is our hidden layer. In the next output layer, no, they will combine this head and body, and they will detect, okay, is it koala or not? Actually, this is how, no, the CNN will work. In the, you know, this is how the CNN, the convolution neural network, it will work. For example, even if you want to, the well-known the computer vision application is digit recognition, handwritten digit recognition application. This is the well-known application. No, even if you search in the internet, you will get a code. Actually, in the convolution, in the digit handwritten digit recognition, for initially, you know, they will recognize this tiny feature like this, okay, this diagonal line, this curve. No, they will detect, and they will make the loopy circle pattern. Then by, you know, small line, they will make the vertical line, this diagonal line. The finally, you know, they will combine this value as a 9, and they will detect. They will check whether the number is 9 or not. Now you have to understand how can, you know, the computer recognize this tiny feature. How you can, you know, extract this tiny feature, the small feature from the image. Don't know the part that they will use the filter in the convolution neural network. No, when you are designing any CNN, we will use the filter. Okay, there will be a different type of filter. For example, you see this is the 9 in the image 9. If you want to detect this 9, okay, you see, no, wherever, no, you see the wherever the 9, the value 1, it is there. No, there wherever the image is present, no, there it is 1. The other place it is -1. Now you see Okay, you see the black color, it is 1. The white color, no, it is -1. Now, if you want to detect this loopy pattern, no, they will use this loopy pattern filter. Okay. If you want to detect this vertical line, they will use the vertical line filter. If you want to detect this diagonal line, they will use the diagonal line filter. Using that filter, no, they will detect these tiny features. No, for that, no, they will use the simple convolution operation. The simple convolution operation in the sense it is a multiplication. They will take this. They actually, let us assume here the filter size is it is 3 into 3. What they will do now, they will take this value and they will multiply and they will divide this the number of value that is present in this filter. Here the number of value is 9. That is why I am dividing the -1 divided by 9. It is -0.11. Like that again, you have to shift to your filter to the next location. You have to do the multiplication and you have to do this. Okay, this is how no they will generate. Now you see, if you look at no in this value, no, you are getting 1. The other place, no, 1, 11, 33. It means that this is your feature. The other value, no, the value it is comes as a negative number, no, that is not relevant to your application. You see, suppose if you are, this is your number digit 9, and if you are having the loopy pattern detector, okay, the loopy pattern, no, this is the loopy pattern detector, then automatically, no, here only you will be getting 1. Suppose if it is 6, and if you are applying the loopy pattern detector, here only you will get 1. You see, suppose if it is 9, 6, okay, for the 9 you will get a loopy pattern detector here. For 6 you will get a here. Even this image, no, it will, even if it goes to the 6 and 9, if it change also, it is not a problem. Okay, automatically what will happen? This future, no, the future position it will change. Whereas in the artificial neural network, no, the image position, if it not change also, it will not recognize. Okay, that is the the problem that is present in the ANN. Especially in the convolution neural network, no, the filter is used to detect the futures. Actually, this you have to understand. The reason is no, the convolution neural network is it is a base for your computer vision application. You can do the face recognition. Any application you can know, you can usually you can develop it. Okay, if you want to modify that algorithm, no, you should understand you should have the basic knowledge of the convolution neural network. That is why I'm discussing this. Okay, the filter, no, it is used to detect the future. For example, you consider this the same Cola application. Initially, for example, the eye detector. If you are having the eye detector filter, if you apply to this image, automatically there are 2 eyes. It will detect. Even if now the image is here, the image now this image position it is changed. If you apply, automatically it will detect. Okay, this is the location invariant. It can detect the eye in any location of the image, but in the ANN in artificial neural network, it is not possible. For example, you see, if there are 3 cola, in the 3 cola, if you want to detect all the, let us assume in the 3 cola, we are having the 5 eyes. For the first cola, no, we are not having the only 1 eye. We are not having the 2 eye. You see, it is detecting all the 5 eyes. Okay, especially this filter, no, it is used to you can detect the feature that is present in your neural in your image. You see the hand detector feature filter. If you apply, if the hand is present here, then automatically detect that feature. Okay, no, in the convolution neural network, no, they will use the different types of filter. Then as well as they will use the n number of filter with the different size. Okay, using the filter, no, they will generate the feature map. Then once if you generate the future map, no, again it is passed to the next layer. They will combine all this feature and they will make as a head. You see, this is my image. Okay, your image, you have to give it to the all the filter. Okay, the filter it will detect eye, nose, ears, hands, legs. You have to combine as a head and you have to combine as a body. Then you have to flatten all this input. You have to convert as a single dimensional input. Okay, using the single dimensional input, you have to pass it to your output layer. In the output layer, no, they will detect, okay, is this cola or not? Okay, this is how, no, this is how they will do this image classification using convolution neural network. Even in the convolution neural network, it is divided into 2 parts. The first one is future extraction. The second part is classification. In the future extraction, no, you need to extract the future. that is passed to your output layer. The output layer, no, it will classify is this koala or not. This is where the classification has been performed. You see, in the the loopy pattern filter, you see we are having this negative value. This negative value, no, it is not at all. It is required. No, even if you use this, no, the value, no, the negative value in your deep neural network, no, it will not, it will, you will get the vanishing gradient problem. To avoid that, what they will use this rectifier linear unit activation function. This rectifier linear unit activation function, what it will do, no, if any negative values comes, it will make it as a 0. The other value it will write as it is. Okay, it is very simple. If any value, if it comes negative, it will make it as a 0. The other value it will write as it is. That is why you see this 1, 11, and 33. The 1 and 11 and 33 is our futures. Okay, in the no, that is our future. It is detected and it is kept as it is. Okay, the for that they will use this ReLU. Now, already I told you one of the disadvantage of the artificial neural network is it will take a huge amount of computing power. Okay, that is why we should not use the ANN, we have to use the CNN. Still, this example we have not discussed about the image size is not reduced. We have not reduced the image. Only we have discussed how we can detect the features that is present in the image. Now, we will discuss how we have to reduce the image size. If you are not reducing the image size and if you are processing your computer system, it will take the huge amount of computing power. Okay, to avoid that, you have to reduce the image. To reduce the image, you see, my image is 1920 to 1080. Okay, I have applied the filter and I have generated the head body. Again, my image it is in same size. Now, to reduce the image size, they will use the polling. The polling is a layer. It is used to can reduce the image size. There are two things in the convolution neural network you have to remember: the filter and the polling. Using the filter, you can detect the feature. Using the polling, what you can do, you can reduce the image size. You see, there are different types of polling. Like in the filter, we are having the different types of filter. Like in the polling, we are having the different types of polling: max polling, average polling, the min polling. In the max polling, what they will do? Actually, you see here the polling size, my filter size, it is 2 into 2. Now, what I will do in this 2 into 2 matrix, which is having the highest value, the 8, I will take 8 and I will write as it is. In this 2 into 2 matrix, which is the highest value, 9, I will take this 9 and I will write as it is. Okay, like in this rectangle, which is the highest value, 3. In this rectangle, which is the highest value, 2. Okay, this is this is how, if my image, if it is 4 into 4, if you want to reduce 2 into 2, you can using the max polling, you can reduce it. This is the average polling. In the average polling, in this rectangle, in this in this square, in this matrix, they will do this average and they will write here the average is 4. In this in this matrix, the average is 4.5. They have written this 4.5 as it is. This is how they will reduce the image size. You see, in the convolution neural network, the first we will apply the filter. Using the filter, you will detect the future. Then after that, using this rectifier linear unit activation function, usually they will use this rectifier linear unit activation function in the hidden layer. Using this rectifier linear unit activation function, what they will do? They will remove the unwanted things that is present in your filter. Okay, then they will pass it to the pooling. The pooling is a layer. Using that layer, what they will do? They will reduce the image size. Okay, you see. Okay, actually, this is the final. This is the final convolution neural network outcome. You see, initially they will, if you are giving any input image as a input, the convolution neural network, it will detect the eye, nose, ears. Then it will apply the rectified linear unit activation function. It will remove that, the unwanted things that is present in your image. Then it is passed to the pooling layer. The pooling layer, it will reduce your image size. Again, you can apply the convolution operation under ReLU. Then you can do pooling. It is depends upon your, your wish. Actually, the convolution neural network, you can have a number of pooling layer and number of convolution layer. It is up to you. Okay, even if you make some complicated network, it doesn't mean that you will get a good accuracy. Okay, the deciding number of layer, number of parameter, that is the other point of research. The many person they are doing it. Okay, no, you need to find out the best model. Okay, how many layer, how many neuron that is required for your model, that you need to decide by doing the experiment. No, now even in the keras, the actually this number of layer, number of parameter, that is hyperparameter tuning. To tune your hyperparameter in the keras, the keras is this high level interface, the high level package that is available in the keras. There is a package called keras tuner. Using the keras tuner, you can fine tune and you can find out how many hidden layer, how many filter, how many neuron you want to use it in your convolution neural network. Then even in the AWS cloud also, there is a Amazon SageMaker. Using the Amazon SageMaker also, you can give your model detail to the Amazon SageMaker. The Amazon SageMaker, it will find out how many neuron, how many um, filter you want to use it to your model. Okay, that is available. You can take it. Now you see, this is the convolution neural network. It will detect the feature. Then using the this is my filter. Okay, I will detect the feature. Then using the pooling layer, I will reduce the image. Again, you can apply. Again, you can apply this convolution and rectify linear unit. Again, you can do the pooling. Then finally you have to flatten. You have to convert your input. No, here your input it will be in the multi-dimensional. You have to convert your input into a single dimensional, and you can process it and you can check whether the given image is this color or not. Actually, no. And actually, this CNN is anyone, if they want to do a project, or if they want to do their research without knowing the convolution neural network, it is not possible. So that is why I have given. This is this is the overall view. Even if you want to develop a code, if you're having this background knowledge, easily you can develop a code. I will show you the simple demonstration so that you can understand. See, I'm going to start my Jupyter notebook. Actually, if you want to work out any the deep learning related application, you need to install Anaconda. Already, you have to install Anaconda. Then you have to start your Jupyter notebook. I'm going to start my Jupyter notebook. I will show you. Actually, my system is very slow. That's why it is taking time to load. Uh, Actually, I don't want to run this application. If I run this application, it will take time. You see the TensorFlow, actually only, actually this is a small application, small image classification using convolution neural network. No, I will show you the difference between the ANN and convolution neural network. You see, in this project, no, they have used only the TensorFlow. If you wanted to work with the computer vision application, the first thing, no, you should learn TensorFlow, Keras, the OpenCV. The OpenCV also, it is a good library. Using that, no, you can write 4 or 5 line of code. Using that, you can write the object detection, object recognition application. Easily, you can write it. Okay, the OpenCV also, it is very important. Actually, I am not going to discuss about OpenCV. That is also, it is very simple. You can know using the Python, easily you can learn it. You see here, I am using the TensorFlow. I am using TensorFlow. The Matplotlib, it is for data visualization. The NumPy, it is for numerical computation. Especially if you want to work with the computer vision related application, you have to learn TensorFlow. Matplotlib for visualization purpose, you have to learn Matplotlib. The NumPy for numerical computation. Then the Pandas also. The Pandas and Matplotlib, it is for data visualization. Pandas also you have to learn. Then the Keras. If you want to do some higher level application, you have to use a Keras. Then OpenCV. Okay, these are the package. It is very, very important. You have to learn. Now you see, actually the CIFR10. This is the data set. It is available in the TensorFlow. It is available in the TensorFlow. I am loading this data set. Okay, I am loading this data set, training data set and testing data set. The training data set, it is stored in this X variable, X train, and the testing data set, no, it is stored in the Y train and Y test. Actually, the X it indicate that is your input variable, the Y is your output variable. The X is your independent variable, the Y is your output, the dependent variable. Using this X only, you need to predict your output. Okay, this is your independent, this is your dependent. Okay, I have loaded the data set and I have divided as a training and testing data set, and I have assigned to this variable. You see, I am having the 50,000 image in the training. I have printed this training data set safe. I am having the 50,000 image. Then you see, I am having the 32, 32, 3. Actually, this each image size, no, it is the 32, 32. Height is 32. Width is 32. The 3 it indicated is a color image. Next I am printing the tested data set. In the tested data set, no, I am having the 10,000 image. 10,000 image. Okay, the same thing. The same thing. 32, 32, 3. Then actually they are just just using the Matplotlib, just I'm printing the image. Just if you want to do any image classification, object detection application, the first thing you have to understand about your data set. What is the number of training example? What is the image size? Then you have to print the data sets also. You have to print the image also. Actually, this is very tinny image. Here, this image quality is not good. It is not it is not printed properly. If you print the size as very small, you can view that image. Just then after visualizing your data set, you have to normalize your data set. No, for your images, the image value, it is represented in between 0 to 255. If you take the value in between 0 to 255 and you train your deep neural network or convolution neural network, what will happen? Your model, it will not learn quickly. Your model, it will not give the proper output. Further, what you have to do now? You have to convert this value 0 to 1. Your image usually it is between 0 to 255. If you take that value and if you use as it is, your model, it will not give the correct output. Okay, that is why especially in the deep learning, you have to give a value in the 0 to 1. Okay, that is why I am normalizing the value 0 to 1 by dividing x train divided by 255, x test by dividing 255. Listen, my dear student, here If it is in C or C++ or Java, if you want to divide an array, no, each and every element you have to using the for loop, you have to iterate and you have to divide. Whereas here, no, you can use the operator broadcasting. If you actually here this division, no, it is applied all the value that is present in this X train, X test. Okay, that is the advantage of this, you know, TensorFlow. Here, no, we are applying the operator broadcasting. This operator division, it is applied to all the value that is present in this variable. Okay, it will do this. Then you see, listen, my dear student. Here, what I am doing now, I am using the first. I am building the ANN. I am building the ANN using the ANN. I am doing the image classification. I am building the artificial neural network using that. No, I am doing the image classification. Okay, you see here I am not, no, I am not using any convolution layer. I am not using any pooling layer. I am not using it. I am using one flattened layer. Then I am using a dense layer. That is my first input layer. The image size is, it is 32. It is 3. Then I am using, this is the dense layer is a hidden layer. Then I am using the ReLU is a hidden layer activation function. Then one more dense layer, that softmax. Listen, my dear student, then I am compiling my model as a stochastic gradient descent optimization algorithm. Okay, if you study in detail, now you can understand. I am using this loss function as a the sparse categorical cross entropy. There are different types of loss function you can take and you can use it. The next, you know, the metrics. I want to measure my performance of the model. For that, I am using the metrics as a accuracy. Listen, my dear student. I am no just I am PIT is a method. Using the PIT is a method. You can give the training input and you can give the number of epochs. Here I am giving the number of epochs is 5. You see, I have trained my model for the 5 epochs and it is giving the accuracies. It is a 49. My accuracy of model is, it is a 49. The reason, no, I told you, no, if you use the artificial neural network for the image classification, your model, it is giving the 49 point accuracy. The same the same model I am going to use the CNN, and if you are building a model, no, it will give the more good accuracy. You see in the, listen, my dear student, you see here I am building the CNN. This is the code. This is the code for building a convolution neural network. Listen, my dear student, it is very easy. Easily you can learn. You see in the convolution neural network, the first, actually this is the sequential model only. Your convolution neural network, it is a sequential model only. The first layer is my convolution layer. In the convolution layer, I'm using the 32 filter. This is filter size 3 into 3. The activation function which I use, the ReLU, rectified linear unit activation function. The input steps is 32 into 3. You see, listen, my dear student, the next I'm using the max pooling. Here the pooling layer size is 2 into 2. Again, I am using convolution layer. No, here I am using 64 filter. The filter size is 3 into 3. The activation function which I am using, that convolution layer is ReLU. Then again I am applying max pooling. There are different types of pooling it is available. Max pooling, min pooling. Then you have to pattern. Okay, this input, no, your max pooling, no, it will generate the output in the form of multi-dimensional array. You have to pattern. Using the pattern function, I am patterning. Okay, then the next is the dense layer. This is my intermediate layer. This patterned input, no, again it is converted as a 64 output. The finally the 64 output, it is converted as a 10 output. Actually, this is the output, no, that multi-class classification. If you are giving any input, the output, no, it may be divided into 10 classification. It may be car, it may be, it may be umbrella, or it may be a person, or it may be, there are 10 classifications. It may be fruits. There are 10 different classifications. According to that classification, it will classify and it will give the output. Listen, my dear student, just this is my model. I have created my model. The next you have to compare your model. When you want to compile your model, here I am using the optimization function is the order. There are again, even here also you can use the same stochastic gradient descent optimization function. You can use it. Is up to you. Okay, the last function. This is the matrix which I am using. You see here using the fit function. No, when I am training my model, you see the initially the accuracy was 48. The same, the 5 FH. No, uh, you see here now I am getting my in the 10, you see in the 5 approach, you see in the 5 approach, no, my model, no, it is giving the 70, whereas in the artificial neural network in the 5 approach we got only the 48, but in the convolution neural network, no, 70, at the approach of 10 we are getting the 78. See, this is how, no, this convolution neural network, it is giving the good accuracy than your artificial neural network. Okay, that is why, no, everyone they are interested to build a the computer vision application using the CNN. No, actually the CNN is it is a base model. Even if you know take any technology, the base they will use the CNN. Using the CNN only they will build. That is why, initially you should understand this CNN. Then I have given some sample input image. Using the sample input image, I have detected. Listen, my dear student, all this, in the foreign country, the currently, the people are they are doing a application using this, image classification and image detection, object detection, object tracking. Currently they were doing. For example, I will finally I will tell you what in the our lab we are doing. Listen, my dear student, actually in the face recognition also it is the 10 line of code. I wanted to show you the simple application. Okay. You see, this is one simple application. This Colab code. Even if you search in the internet, you will get a code. The only thing is, listen, my dear student, you have to use your Gmail ID. You have to use your Gmail ID and you have to run. If you are having, even I will keep this. I will pass this link in the chat window. Okay. Okay, and I will end up this session. I will share this PPT. Then using that, you can work on. This is the face recognition application. Okay, if you give any photo, automatically it will detect that the person who is this person. Okay, they will detect, and even if you give your image, for your image also to detect. The thing is, in your data set you have to add your image. You have to you have to make this image. In the image you have to generate the bounding bus. Using the bounding bus manually you have to do a labeling like that. I am Karthikeyan. Okay, this is Venkatesan, this is the professor Kumar. Like that, you need to make your data set. Then after that, using the data set, you need to train your model, and finally you can check. Okay, actually this is one simple application. Now all the code it is available in the internet. Even using your now if you are having your laptop in the the Google, they are providing the GPU. Okay, in the Google, the Colab, using the Colab you can run all your deep learning model and you can generate the output. Is even you can use the Goggle also. The Goggle also it is a data set. There you can download all this data set. The Goggle also they are providing uh, CPU. You can create account in the Goggle also. You can run your CPU application. Listen, my dear student. Currently, the object detection, the YOLO version 4 is it is an important application. the currently in the actually in our lab we are we are developing an object detection application. This is my dear student. Okay, I will show you. Actually, the YOLO it is a well-known application, the object detection application. The deep learning model. Okay, initially they are developed YOLO version 3, version 4. The currently, all the university they are using YOLO version 5. If you want to know, if you are having this link, it is enough. Even if you search in the Google, you can get this link. This my dear student, in the Google, you can type YOLO version 5 colon. In the Google, just you can type YOLO version 5 colon. That's it. If you search now, you will get this link. You see, this is the tutorial. You can get and you can run and you can understand how this object detection algorithm it is working. Okay, you see, I'm opening. In my system, no, my laptop, I'm not having a good. I'm not having a good computing power. That is why it is taking time. You see, listen, my dear student, the YOLO 5, it is rewritten with the help of the TORCH framework. The TORCH also it is one of the deep learning framework. Using that TORCH framework, they have rewritten. That is why here they have imported the TORCH library. YOLO 5, it is available in the GitHub this location. Okay, the first thing is you have to clone that YOLO 5 to your environment. Then after that only you can build an application. This is my dear student. This is the already I told you you can also run this application. For example, it will take time. Okay, if I give this automatically it will take huge amount of computing power, huge amount of data. Also, it need to store it in my device. I don't want to run this application. If you run, automatically it will run without generating any error. Okay, the next it is all the step also here it is available. You see here they are using the COCO data set. Okay, here they are downloading 1 GB, 5,000 image, and they are testing the model accuracy. They have downloaded the COCO data set and they have given some sample image using that image. They have visualized. Okay, they have visualized the result. Listen, my dear student, even you can make your application like this. Even you can make your data set. The question may comes in your mind, sir. Even if I am having some image, for that image, how to make a bounding pass. Even for that to make a bounding box, also there are some tools are available. Or else you can, even it is very simple. You can write a Python code using the Python code. Also, you can generate the bounding box. Okay, you can generate your in some time. For example, in the for your Paavai institution, if you want to make some simple application, you want to make your own data set. Okay, for your lab, you want to detect the XY person, or else you want to detect some XY object. Accordingly, you want to make some decision. In that situation, you have to make your own data set. In the own data set, you want to add it to this COCO data set. Then only it will detect your input. It may not. For example, now the currently I am working on the project. The Taiwan government. The distant water fishing industry. The fishermen they may be the fishermen they are exploited. For example, actually they should work for only the 14 hours. But the fishermen, they are sent to the ship. They are forced to work more than 14 hours. Now, what we are doing, we are developing one application. The application, what it should decide. The application it should decide whether the fishermen they are working more than 14 hours or not. If the XY fishermen if they are working more than 14 hours, our model should detect and our model it should intimate the government officer stating that the fishermen, this XY fishermen, they are working more than 14 hours. Okay, then no that that XY the company they need to give an explanation to the government stating that this fisherman, this because of the reason only they have worked overwork. Okay, currently we are working on this project only. We are working for the Taiwan government. Myself and my professor, we are working on this project. Actually, this is one social issue on this Taiwan fishing industry. They are facing actually the all this USA, all other country they are dominating. They are stating that you are taking the people from the undeveloped country like Indonesia and Vietnam. The people they are coming from Indonesia and Vietnam and they are working. They are the people are overloaded. If the working hour is 14 hours maximum. The minimum is 8, the maximum is 14 hours. But the people they're supposed to work 16 or 20 hours. Then the people they are working only the 4 hours. Because of that, the many people they are doing the suicide also. Because of that, the Taiwan is the banned for 1 or 2 years to not to do the fishing in the distant water. Okay, actually in Tamil we will say there's alkadal mean pidipu. When they are doing this distant water fishing industry, the Taiwan faced this many issue to solve this issue. I am working with one more professor from the labor department. We are developing a application. Actually, we are using this Volo version 5 is a base model. Using the model only, we are detecting the fishing person. Actually, it is very complicated task. If you want to detect the person in the normal place, like the controlled environment, in a room, if you want to detect easily, you can detect it. But if you want to detect in the ship, it is very tough. The reason is in night the camera will be different angle, the rain will be there, they will wear the raincoat. Then there will be the image, it will not be clear. We are having lot of challenge to solve this lot of challenge only. We are developing a application. Okay, that is the challenge. Actually, with this, I will conclude this my session. Once again, I thank the Paavai institution and the organizing committee for inviting me on this special day. If you are having any query or else if you are having anything, if you want to ask, you can ask, so that the 5 minutes we will discuss and we will conclude this session.
Thank you, sir. Application makes speech important than any else. I kindly call upon P. Niranjan Kumar from third year of Information Technology to deliver vote of thanks.
A warm good evening to my friend here. I thank this wonderful opportunity to propose the vote of thanks in this great occasion. I thank this opportunity to thank Speaker of the Day, our chief guest, Dr. P. Karthikeyan, for enlightening us with as valuable and inspiration ideas and thoughts. Thank you, sir. I would like to thank our principal for his valuable guidance and support. Thank you, sir. I would like to thank our HOD for his valuable guidance and support. Thank you, sir. I also extend my sincere thanks to all the HODs, staff members, and my dear brothers and sisters. Once again, thank you all.
Thank you, brother.